Last time, we untangled the two voltages in a three-phase system. Now the question every engineer actually asks, how much power is a three-phase load drawing? The good news is, it comes down to one clean formula. And here's the curious part. That root 3 from last video shows up in it again. But why when there's nothing to subtract this time? Let's build the formula, then use it on a real load. Start with just one phase. The power it delivers is simple. It's voltage times its current times something called the power factor. The power factor, written cosine theta, is a number between 0 and 1. It tells you how much of that current is doing real work, instead of just sloshing back and forth. A perfect resistor sits at 1, a typical motor around 0.8. For now, think of it as a dial. So, for one phase, voltage times current times the power factor. Now, a three-phase load is just three of these single phases working together, so the total power is 3 times one phase. 3 times the phase voltage times the phase current times the power factor. But here's the catch from last time. Out in the real world, we don't measure phase voltage, we measure line voltage. And in a Y, the phase voltage is the line voltage divided by root 3, while the line current is the same as the phase current. So we substitute that in. And now watch the numbers. 3 divided by root 3 is exactly root 3. The 3 and the root 3 collapse into a single root 3 sitting out front. And there's our formula. Now, let's use it on a real load. A balanced three-phase load draws 20 amps of line current from a 480-volt line-to-line supply at a power factor of 0.8. We just drop the numbers into the formula. Power equals root 3 times 480 times 20 times 0.8. Root 3 is about 1.73. Multiply it all through, and you land on 13,302 watts. Round it off, and that's about 13.3 kilowatts of real power. One formula, real numbers, done. So, three-phase power. The real power a load draws is root 3 times the line voltage times the line current times the power factor. And that root 3 came back for a brand new reason. Not from subtracting two voltages, but from three phases sharing the line, 3 over root 3. We even put it to work and found a real load pulling 13.3 kilowatts. Next time, we'll meet the other connection, the delta, and find out where the root 3 hides inside it. Subscribe, and I'll see you in the next one.